Hi, we will continue our discussion on the types of generators, and also we will see where the generators can be used, that is application of generators. So as we discussed in the previous session, we will classify the generators based on how we provide the current to the field winding as separately excited and self-excited. Separately excited generator in the sense we use a separate external DC supply to pass the current to the field winding, and if we use the armature current itself as a field current, then we call them as a self-excited generator. And further, the self-excited generator can be classified as um, series, shunt, and then compound generator, depending on how the field windings are connected with the armature. So we also discussed in series generator, the field winding will be connected in series to the armature, and in shunt generator the field windings will be connected in parallel to the armature. Okay, and also the another type is compound generator. So in this type, a part of the field winding will be connected in parallel to the armature, and the another part of the field winding will be connected in series with the armature. So basically, it contains the combination of both series and then parallel to the armature. So depending on the connection of shunt and series field winding, the compound generators further can be classified as long shunt compound generator and then short shunt compound generator. So we will consider long shunt compound generator first. Okay, here. So this is the structure of long shunt compound generator looks like. So here we can observe that some part of the field windings are connected in series to the armature, and some part is connected in parallel to the armature. That is, the shunt field winding is connected across the series combination of armature and the series field winding. So this is the series combination of armature and the field winding. So for this series combination, the field winding, if it is connected in parallel, we call such arrangement as long shunt compound generator, and the load is connected in for this parallel and series combination, and Vt is the terminal voltage. Just see the direction of the currents over here. So Ia is the armature current. Armature current flows like this, Ia, and the same current will be flowing through this series field winding having the resistance as RSE, and this field current we call it as ISE. ISE is the series field current, and IL is the load current, and ISH is the shunt field current. So you can observe here the armature current IA is equals to ISE. Okay, and at this point the current should be divided because there is a node over here. So ISE or IA will be divided as IL and ISH. I repeat, ISE at this nodal point will be divided as IL and ISH. So we can write the expression for the current as Ia is equal to ISE and Ia as or ISE as IL plus ISH. Okay, so this Ia should be equals to ISE, and this Ia or ISE should be equals to IL plus ISH. Okay, IL plus ISH, and here, so this voltage across this parallel field winding and this load will be the same. Therefore, we can calculate this parallel field winding resistors by making use of the terminal voltage Vt and the ISH value. Okay, so similar to the parallel generators. Okay, therefore RSH can be expressed as Vt by ISH, or ISH can be expressed as Vt by uh, RSH. So ISH, the parallel field current, can be calculated as terminal voltage divided by RSH. Okay, and to write the expression for EMF, let us consider this loop. Okay, let us consider this loop here. So just observe what are the parameters associated. It has the EMF, the brush contact drop, armature resistance voltage drop, that is IA into RA, and here the field resistance drop, series field resistance drop, which is IAC into RAC and VT. Okay, similar to the series generator, we get the expression for EMF, that is EMF E is equal to VT plus IARA plus IAC into RAC. Since I have told that IAC is RAC, we have just written them as IA into RAC, and plus equals to V brush. V reaction drop is negligible, so I have not included. Even V brush is negligible, you can ignore even this parameter. Okay, right. Now let us move with the short shunt compound generator. In short shunt compound generator, uh, we will have the field winding which is connected in parallel to the armature, and this, for this parallel combination, the field winding will be connected. Okay, so I repeat, this parallel field winding is connected in parallel to the armature. Field winding is connected in parallel to the armature, and this entire parallel combination is connected in series to the another field winding. And for this combination, the load is being connected. In observe the difference. In long shunt, the field winding is connected to the series combination of armature and the series field winding. But here in short shunt compound generator, the field winding is connected to the parallel combination of field winding, parallel field winding and the armature. Okay, so we can just observe the current and the voltage expression in this circuit. So armature current is IA. So here there is a node, right? So at this point the current will be divided between this series field winding and this parallel field winding. Therefore, this armature current IA can be written as sum of this IAC and ISH. I repeat, this current will be divided at this nodal point in between this series field winding and the parallel field winding. Therefore, IA is equals to IAC plus ISH. This expression we can write according to KCL. Okay, and here look at this other side. This series field current, that is IAC, flows like this and it passes through the load. Therefore, this series field current ISE is same as that of the load current. Therefore, we can write ISE is equal to IL. And since ISE is equal to IL, we can also write armature current IA as IL plus ISH. So, in this expression, replacing ISE with IL, we can write IA as IL plus ISH. Okay, so this expression. Okay, right. Now we will move to the voltage expression. So the voltage expression can be written by considering this loop, considering this loop. Okay, so that is V is equal to VT, IARA, IAC, RAC plus V brush. Similar to the series generator, we can write. So E plus IARA plus V brush plus IAC, RAC plus VT will gives the expression for the EMF. Okay. So VT plus IARA plus IAC, RAC and V brush. But IAC can also be written as IL. So you can replace IAC with IL and rewrite the alternate expression for the EMF. So by neglecting the V brush, we can also write the expression for the EMF as this. And also in this expression, we can write E minus IA into RA as VT plus IL RAC. And from this, we can rewrite the expression for ISH as VT plus IL RAC divided by RSH, because here E minus IA into RA can be considered as ISH into RSH. So this portion V minus, okay, 1 second. So this voltage drop, the voltage drop at this is same as at this terminals, right? So this voltage is nothing but E minus IA into RA, which is equals to, otherwise IAC into RSH. You can just do one more thing, simply apply KVL to this small loop, which is ISH RSH plus IA RA plus which is equals to E. Therefore, ISH can be written as E minus IARA divided by RSH. Hence, we can write, so E minus IA into RA as ISH into RSH. Therefore, ISH can be calculated as VT plus ILRAC divided by RSH. Okay. Next, moving on to the application of various types of DC generators. So, the separately excited DC generators can be used for the special applications like electroplating, electro-refining of the material. Separately excited generators are used for electroplating and electro-refining of the material. Next, shunt generators can be used in battery charging and for ordinary lighting purpose. Series generators, they are used for boosters, as a booster on DC feeder, and also as a constant current generator for welding machines and then arc lamps. Okay, so they are used for welding machines, arc lamps, as a booster on the DC feeders. Next, cumulatively compound generators can be used for the domestic lighting purpose, and the differential compound generators are used for the special applications like electric arc winding. Okay, so these are the different applications of the DC generators. Thank you.